everyone. This week we are going to start our new unit, and it is linear relations. It's very closely related to the linear equations unit that we did before circle geometry. Okay, so let's have a look. So our goal for this week is to be able to identify a pattern and to write an equation to represent the pattern. And that equation is going to help us predict the pattern in an easier way. Your resources this week are the video that you're watching right now, and there's some extra videos here. And for extra practice, you can use your workbooks 4.1. Alright, so we see patterns everywhere. We use patterns to predict what's going to happen next. Now that we are really good at solving linear equations, we are now going to use a linear equation to represent the pattern so that we can use the equation to help us predict future outcomes. And here's when it becomes really handy. So if you look at the figure, the example that's in the introduction box right there, okay, this one right here, if we were asked to figure out what figure 5 will look like, that's pretty easy. We just continue the pattern and draw our fifth figure. But if the question asked us to get the figure 102, it will take us forever to draw all the way up to 102, and we're going to be more prone to making mistakes. So instead of the drawing method, now we're going to use a linear equation to represent what's happening in this example so that we can just solve using numbers instead of drawing every single figure. Okay, all right, so let's go over how we come up with a linear equation. Okay, all right, so we're going to describe this pictorial pattern using a linear equation. First, let's describe the pattern. What is happening with each figure? So in figure number 1, I have one little square, and in figure number 2, I have 1, 2, 3, 4. In figure 3, it looks like I have 3 added on, so I have 1, 2, 3, 4, 5, 6, 7. In figure 4, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so it looks like my pattern is that I'm adding 3 more little squares to each of the figures. So I'm going to say plus 3 squares for each figure. Right, and then it's asking us to create a table of values to represent the linear relation. So table of values to represent the linear relation. Linear relation means that the figure number and the number of squares are directly related. Okay, between the number of squares and the figure number for the first 4 figures. Okay, so the two things that they want us to compare were number of squares and the figure number. Okay, so in my table, I'm going to go figure number right here. Okay, so figure number is the name of each drawing, so I'm going to write that first. Okay, and then what changes every time is the number of squares. So that goes on the right. Okay. So for figure number 1, I'm just going to fill out the table. I have 1 squares, 2, 4, 3, 7, 4, 10, and I can go one more. Assume what figure number 5 is going to be. Just going to add 3 more, and I have 13. Okay. Now, here is the important part for this week. We need to write a linear equation to represent this pattern. In order for us to write a linear equation, we need some variables. Okay, so let's actually classify a name of some of these and use a variable to represent it. So why don't we use n as figure number and s as number of squares. And like we said before, figure number determines the number of squares. Okay, number of squares changes as the figure number goes up. Okay, right. And here's a trick to how you write an equation. So n is gonna equal to s. Okay, but 1 equals 1. It works for the first one, but 2 does not equal 4. 3 does not equal 7. So we can't just leave it like this. We need to add some numbers to make this true. Okay, all right. So like we said, every time the number of squares increases by 3. If it goes up by a constant number like that, that constant becomes a coefficient of our first variable. So we're going to write the 3 right here. Okay, so again, if a number if the number of squares, okay, if the second column, if it increases by a constant number, okay, that constant becomes the coefficient for our variable n. Okay, and now we just figure out what we need to add to this to make this equation true. Okay, looking at the first one, 3 times n gives us 3. How do we get to 1 from 3? We need to take away 2. Okay, let's see if this works for the second part. 2. So if figure number was 2, so if n is equal to 2, 3 times 2 is 6, minus 2 that gives us 4. And does it match? It does. Okay, let's just check with another one. Let's check with 4 to make sure this works. So if n is equal to 4, 3 times 4 is 12 minus 2 should give us 10, and it matches. So this becomes our linear equation. Pretty simple, right? So we need to look at the constant increase and put that as our coefficient, and then add or subtract to make the equation true. Okay, now that we have an equation, we can easily answer D and E. Okay, so this is our equation, right? And the linear equation was 3n minus 2 is equal to s. All right, next part, how many squares are in figure 2? It's asking for how many squares, so it's asking for s. And it gave us figure 12, so n is equal to 12. So we need to figure out what s is equal to when n is equal to 12. So for D, I'm going to show my work here and use my equation 3n minus 2 is equal to s. The question gave us that n is equal to 12. Minus 2 is s. 36 minus 2 is s. So s is equal to 34. So how many squares are there? There are 34 squares. Okay. Now E, which figure number? So it's asking us for n. What is n? Okay, when it has 106 squares, when s is equal to 106. Okay, so again, we're going to use our equation. Okay, and plug in what we know. So 3n minus 2 is equal to 106. Okay, and we're gonna add 2, add 2. Let's move it over here. 3n is equal to 108. And I'm just gonna divide by 3 on both sides to get my final answer. So 108 divided by 3 gives me 36. So figure 36 has 106 squares. So figure 36 has 106 squares, but I'm not done because it says to verify my answer. And I'm gonna verify using method that we used before, okay? So I'm gonna say 3n minus 2 is equal to s. Okay, when n is 36, I'm gonna verify and see if s is equal to 106. So 3 times 36 gives us 108. Minus 2 equals 106. 106 is equal to 106, so it is verified. So figure number 36 has 106 squares. Okay, see how the later two parts are just solving equations, and you've done that before. Okay, so we are good to go with that. Okay, let's try a few more questions. Okay, so that we can be familiar with making equations. Okay, oh, where's our second page? Let's use this one. Okay, we're going to look at this page right here. How do I get rid of these numbers? Okay, maybe I'll just erase it. Okay, so example number 2. Describing same thing. We're going to describe a pictorial pattern using linear equation. Okay. Here is a pattern made from square tiles, and it gives us figure 1, 2, and 3. First, same thing, we're going to describe the pattern. So figure 1 has a total of 7 squares. Figure 2 has 1, 2, 3, 4, 5, 6, 7, 8. Figure 3 looks like has 9. So it's going up by 1 every time. Okay, so plus 1, and then looks like the red squares are going up. Square for each figure. There's our pattern. create a table of values to represent the relation between figure number and number of the square tiles. So I'm always going to write figure number first. Okay, and then whatever's changing, so number of square tiles. Okay. Write a linear, I'm not done filling out my table, so I'm just going to fill it out. Figure 1, 2, 3, 1 had 7, 2 had 8, 3 had 9, so if I keep going, it looks like it's just going to increase by 1 every time. Okay, and now I have to write a linear equation to represent this pattern. Okay, so again, every time it goes up by 1. So 1 is going to be our coefficient. Okay, so this is very similar to what we did. So let's actually name this n and name this s. Okay, so n has to equal s, and we need to come up with a relation between the two, and it looks like the coefficient for n is going to be 1. Okay, so if coefficient for n is going to be 1, okay, how do I get to 7? So 1 times 1 is 1. How do I get to 7? I need to add 6. Okay, let's see if it works for other ones. 2 times 1 plus 6 is 8. 3 times 1 plus 6 is 9. Okay, so it works for all the other ones. Okay, so the linear equation for this one becomes 1n, which is just n, plus 6 is equal to s. Okay. How many squares are in figure 20? So it's telling us that n is equal to 20. So when n is equal to 20, it becomes 20 plus 6 is equal to s, which is 26. So there is a total of 26 squares. Okay, this one you don't have to show your work verifying because it's easy for us to see that 20 plus 6 is equal to 26, right? All right, which figure number has 1,955 squares? So this is especially when it really becomes handy, because we don't want to be drawing 1,955 squares, right? All right, so S in this question is equal to 1,955. Okay, we just plug it into our equation, 1,955, and we are solving for which figure number? So we're solving for n. Okay, in order to do that, we just isolate for n. N is equal to 1,949. Okay, so it is going to be at figure 1,949 is going to have 1,955 squares. Okay, so again, we use the same method to come up with our linear equation, and we use this linear equation to help us solve questions like D and E. Okay, let's move on to example number 3, our last example. Sometimes it's not going to be given to you in pictures, it's going to be given to you in words. And as we do this, you're going to see that, hey, we've actually seen this before when we did word problems with linear equations. So we have been working with patterns before. All right, looking at this question, Sully gets hired to make hand sanitizers. They are in very high demand right now. He'll be paid $250 per week and an additional of $3 for every bottle of hand sanitizer he makes. Okay, so the two things that relates in this question are the money he makes. Okay, we're just gonna reset. Okay, so the money he makes relates directly to, okay, what does it relate to? Okay, what determines how much he's gonna make in a week? Okay, he's gonna get paid $250 for sure. Okay, but he's also gonna be paid more for the number of bottles he makes. So it relates directly to number of bottles of sanitizer he makes. Those are the two things that we're going to compare. So write an equation to represent this pattern. Okay, so we need to come up with a variable to represent the two things that we're relating. So money he makes, let's represent this as D. Dollars that he makes is equal to, directly related to the bottles of sanitizer he makes. Let's use S for sanitizer. Okay, write an equation to represent the pattern. Okay, it looks like, okay, he's going to be paid $250 as his base, Okay, and he's earning additional $3 for every bottle. Okay, if you'd like, you can make a table. Okay, money he makes and the bottle number of bottles. So if he makes 0 bottles, he still makes $250. If he makes 1, he makes $253. If he makes 2 bottles, he's gonna make $3 more on top of that. Okay, and see how it goes up by $3 every time. Okay, so 3 becomes our coefficient. Okay, so 3 times the number of bottle he makes, okay, plus 250, his base rate is gonna give him, it's gonna go to the money he makes. Okay, so that is our equation here. Okay, and see how this is very similar to equations that we made for word problems before. Okay, and then we're just gonna solve C and D using this equation right here. How much does he make in a week? If he makes 82 bottles that week. So if S is equal to 82, what is D equal to? So we go 3 times 82 plus 250 is equal to money he makes. 3 times 82 gives us 246 plus 250 is equal to money he makes. He's going to make a total of $496 if he makes 82 bottles. So we're going to write 496. Okay. All right, for D, I'm just going to delete this part so I have more room. Okay, how many bottles does he need to make in order to earn a total of $700 in a week? So we want to earn $700, and we have to figure out how many bottles he needs to make in order for him to make $700. So we're going to use the equation again. For D, we're going to put 700. And we're going to solve for our S. 700 minus 250 gives us 450 divided by 3 on both sides. And S is equal to 150. Okay, so he needs to make 150 bottles. Okay, see how it becomes really easy for us to get the answers to big numbers like these when we have an equation. Okay, so that's how you come up with an equation to represent the pattern that you see. Okay, you are very familiar with them, so try the practice questions in week 7 task 1 and take a picture of your finished work and upload it once you're done. And as always, you can email me with any questions.